Hello everyone. So in our last lecture we have learned about the performance engineering, what is the performance engineering and walkthrough of the course syllabus. So now in upcoming lectures and upcoming videos I'm going to cover these two topics, performance engineering life cycle and activities performed by the performance engineering. So let's go to the performance engineering life cycle first. So basically, performance engineering is nothing but a next steps towards the performance testing. So in performance testing, normally we do the performance test of the different kind of load testing, endurance testing, volume testing, and present the number. But in performance engineering, we need to provide the why the any number is bad, why the response time is high, how we can improve the application performance. So these all details are covered as a part of a performance engineer. So I will walk through this performance engineering life cycle, what is performance engineering life cycle, and how performance engineering work, how what are the activities performance engineers needs to be performed. So these are all covered in this videos. I'm going to walk through all this. Yeah, so first one is the requirement gathering, analysis, system sizing. So as a part of performance engineers, we need to focus on the requirement gathering. What are the non-functional requirement, what are the business critical transactions. See, all details are covered as a part of the requirement gathering. Right number of the resources to provide the satisfactory performance. So we should have a right number of the resources that provide the satisfactory performance. Let's say if we are doing a performance testing and we don't have enough memory, or we don't have enough CPU, so definitely we don't have enough resource, so that will definitely causes a issue in response time or in a high CPU utilization. So we first of all we should have enough resource utilization. We should have enough resources to perform the performance testing growth rate. So let's say this year we are testing with 1,000 users, and next year suppose in a production 2,000 users are going to access the application. So we should have enough resource or enough environment available to test our application should be able to sustain with the increasing in a users count. Storage requirement, storage is nothing but right now we have 35 million of storage database, and this is going to be increased with 70 million. So we should have enough storage to store the data in our database. And user response time, we should have predefined SLA for each and every transaction. Let's say for login transaction we have 2 seconds of SLA. So whenever 1,000 users are accessing the application, that should mitigate, that should that all users are able to log in within the 2 seconds of response time. So we should have all the SLA of each and every transactions that were covered as a part of performance testing. Number of concurrent users, we should have count of user that we are going to test. We should have production similar, we are able to replicate the production like environment. We should have workload, proper workload diagram, so that we can identify how many users are required to perform the test. So and our application should be able to handle the concurrent number of user load at the same time. Peak transaction is nothing but there are some e-commerce website where sales are going on at a time, number of user count are increased while accessing the application. There are some offer period or some holiday seasons are going on at a time, number of users are accessing their application is higher. So we should have that data, so that we can test our application with the peak users and peak transactions during that period, so that application is not going to crash whenever there is some offer or sale or any like festivals is going on. So this is all about the requirement gathering part. Next one is architecture. So as a performance engineer we should be aware of the architecture of the application. So basically we should understand what is the application architecture, simple design and implementation, choose the right algorithm and data structure, architect limitation and documentation. So basically in general there are the three layers in any application. One is a web server, another is application server, and third one is database server. Yeah, so I just give you a high overview of what is all three about. Yeah, so For web servers, a web server is responsible for handling the HTTP requests from the client, usually web browser, and returning the appropriate HTML, CSS, and other static content. It primarily deals with serving static file like HTML pages, images, style sheet, and client-side script. For example, JavaScript we can say. And yeah, so for example, web service include the Apache HTTP server, Microsoft Internet Information Services, and next one is the application server. Application is server is nothing but containing the business logic for responsible for executing the business logic of a web application and generating a dynamic content in the response of client request. It typically handles more complex tasks such as processing user input, interacting with database, and executing server-side script. For example, we can say is Apache Tomcat, Wildfly, JBoss, and Microsoft Internet Information Service (IIS). That we can say is application server. Database server nothing but stores and manages the data used by the application. That comes under the database server. It handles read and write operation and form a database. Database server ensures data integrity, security, and efficient retrieval and storage information. Example of the database server is MS SQL, Microsoft SQL, Oracle DB, DB2. So these three things basically we need to understand, because whenever we execute the performance test and we say high response time, then we need to identify in which layer causing the issue that directly impacting the high response time. Is it a web server layer, application layer, or database layer? Web server layer, we can see the HTML files. Here it's a business logic and storage data. Next one is scale up and scale out. So scale up and scale out is nothing but, let me explain, draw diagram. Yeah, what is scale up and what is scale out? Let's say I have one server which has a 6 GB of RAM, and I am facing like high memory utilization during my performance test. So what I will do, in a scale up I will increase RAM of 6 GB to 12 GB, and subsequently I will increase to 32 GB in a single server. But there are some point where we cannot increase our RAM, so this is called scale up or vertical scale. Or vertical. So there are some certain point that we cannot increase our RAM. So in that case, we need to going to the scale out or horizontal increase the server. So I will deploy another server having a 32 GB RAM, server 2, 32 GB RAM. Yeah, so this is called a horizontal scale out. So once I deploy the another server, I will do the load balance, which distribute the load on both the server. This is called load balancer. So this is how we are doing scale up and scale out. So this is 2 is also covered. Next one is a deployment of code optimizer. So in a performance engineering life cycle, so we need to understand what is the deployment of code optimizer. So first one is a remove the redundancy in the code. So it is nothing but refers to the practice of identifying and eliminating unnecessary duplication of the code within a software program. Redundancy in a code occurs when the same or similar logic is repeated in multiple places within the code database. So we need to identify, because mostly this part is also done by the performance test engineer. In a real scenario, we have seen like all the developers are working in a sprint cycle, so they need to finish their work and code in a weekly sprint cycle, so they don't have much time to look into the issue. So we need to identify this issue and provide them details. So this redundancy can lead to the several issues, including increased maintenance effort, potential for inconsistency, and higher likelihood for introducing bugs. So for that we need to analyze the code base to identify instance where the same or similar logic is implemented in multiple locations. This refers to code by considering duplicate logic into the reusable functions or modules. By creating modular and reusable code, we reduce redundancy to and make the code base more maintainable. So this comes under the remove redundancy in the code. Next one is implement simple logic with minimum resource utilization. So for this involves achieving the desired functionality with the least amount of computational resources such as memory, processing power, and network bandwidth. Writing efficient code helps reduce the overall resource footprint of the application. So in the context of the algorithm, we can see choose algorithm and data structure that have low algorithm complexity, optimize for algorithm with a lower time and space complexity to ensure that the code performs well, especially when dealing with a large data set. Next one is like we can say avoid the redundancy that we already cover in the terms of the IO operations. Input and output operations such as reading from or writing to files or database can be sorry reduce intensive, minimize unnecessary IO operation, and optimize the one that are necessary for the application functionality. Next one, in terms of memory management, we are supposed to be mindful of the memory usage. Efficient manage memory by releasing the resources when they are no longer needed, avoiding memory leaks, and using the sorry appropriate data structure to minimize the memory overhead. Sorry. Next one is a rewrite some part of the code. In this section, practice of the rewriting or modifying specific section of the software program to improve the performance, readability, and maintainability. This can be part of broader effort to enhance the overall quality of the code base. What are the optimized techniques? So optimized techniques refer to the method of approach used to enhance and improve the performance, efficiency, or effectiveness of system, processes, or code in the context of software development and programming. Optimized techniques are applied to make a program run faster, run fewer, use fewer resources, or achieve better result. There are some techniques that we can consider during the optimized techniques. So for example, load balancing, distribute workload across the multiple resources to optimize the resource utilization and prevent overload on a specific component. For example, if we consider profiling, identifying the performance bottleneck by using the profiling tool to analyze and runtime behavior of the application. In the terms of the database optimizer, improve the performance of the database query and transaction by optimizing indexing, query structure, and database design. In terms of catching, storing, and reducing the previously computed result or data to avoid the redundant computation. In terms of memory optimization, reduce the memory footprints of a program by optimizing data structure, minimizing memory leak, or using a more efficient memory allocation strategies. This all comes under the optimization techniques. Next one is a testing proficiency, performance testing, and tuning. So execute the various test type. So there are the different tests we are doing as a performance tester. For example, load test, stress test, endurance test, scalability test, volume test. That all covers under the execute the various tests. So in a load test, normally we have predefined a number of users. For example, I am doing 100 users load test for 1 hour. So that numbers comes from the workload diagram. Stress test is nothing but testing the application to check the breaking point of the system. I will increase my user load from X to 2X to 3X until the system get break. That comes under the stress test. Endurance test is nothing, it is also called as a soak test. Testing the application for the longer period of time to check the memory leak. For example, we are testing our application with 100 users load in a 1 hour. So I will execute the same user load for a 12 hours or 24 hours. Nowadays in industry we are not doing executing these tests for 24 hours. We maximum execute for the 4 hours or 8 hours to check the how the all the KPIs behave during the endurance stage, if application is able to sustain the load for a longer period of time. Scalability test, testing the application in the current infrastructure with the future load. For example, right now I have infrastructure ready and I am doing 100 user load test, and in future we have like around 200-300 users requirement. So right now with the current infrastructure I will test my application with a 200 or 300 user load. That comes under the scalability test. What is the volume test? Volume test is testing the application scenario where we have more database interaction. So it is related to the database interaction. We are fetching, we are executing like a query, getting if we are getting a successful response or not, all comes under the volume test. Okay, next one is various workload. So workload diagram is nothing but we need to get a data from the production environment, and we need to prepare a workload diagram so that we can replicate the same load, similar kind of load in our current environment, which is similar to the production like environment. So let's say we have yearly, like if we have data yearly we have 20 million users are accessing our application, so we will replicate the same user load in our current environment as per the scalability of the environment. Like we have like testing environment, it is 50% scalable of the production environment. So accordingly we need to design the workload diagram. So next one is a production like scenario. Production like scenario, as I said, we need to get a data from the production, how many users are accessing the application in a 1 year or in a quarter, what are the peak transactions, what are the business critical transactions. That all comes under the production like scenario. I have seen many organizations like people are equally distributing the load for all the transactions, but in a real scenario production it is not happening like that. There are some transactions where users loads are higher. For example, payment transaction, if I considering doing a payment of any e-commerce banking domain, the payment transaction is higher. So if we put equally distributed load, then we never come across the production like scenario where the load is higher on a particular transaction. So we need to identify that transaction where the load is higher side, and accordingly we design the scenario. Baseline and benchmark report. So for every sprint cycle we execute the number of tests. So what is the baseline or benchmark report? So baseline is nothing but we for any one sprint cycle or for any one single test cycle, one report I consider as a baseline, which is a good, and I use this report as a reference for the next sprint cycle. So in a next sprint cycle, whatever run I will do, I will compare it with the baseline run. So this is called a baseline report. So yeah, so this comes under the baseline report part. Okay, next one is a little slow. So number of users. So what is the little slow? So this is also very important. So in industry, if we need to find the number of user count, so this is nothing but number of users equal to transaction per second multiplied by response time plus think time. Think time is time taken between the two transaction, and plus pacing. Pacing is nothing but time required between a two iteration. So if we have number transaction per second data and response and think time and spacing data, then we can identify the number of user required to perform or design the scenario to perform the load test. So this is how we can calculate the number of users using the Little's law. Now next one is a production monitoring capacity planning. Production monitoring and capacity planning. Yeah, so for that let's say forecast production problem. So what is the forecast of the production problem? So it is nothing but practice of predicting or anticipating an issue that may arise in the production environment. In the field of performance engineering, forecasting production problem involves the analyzing trend and pattern to make informed prediction about potential challenges that may impact the performance of the system. In terms of monitoring trend, performance engineer as a performance engineer, we use a monitoring tool to collect the data on a various metrics such as CPU utilization, memory utilization, disk IO, and network traffic. By analyzing the trend in the metrics over a time, they can identify patterns that may indicate a potential issue. So this comes under the forecast production problem. What else? So other we can consider as a proactive identification, involves the proactive problems before they escalate into the critical issue. For example, if there is a consistent increase in a resource utilization or specific metrics is trending in a unfavorable direction, so performance engineers may anticipate that it could be lead to a production in the future. So that also we need to identify before we get this issue in the production. In the terms of resource planning, forecasting is closely tied to the capacity planning. Performance engineer assess the current resource usage and project the future needs based on the observed trend. This allows organization to plan for additional resource or optimize to prevent a performance degradation. Early investment also we can say, by forecasting problem, performance engineers can intervene early to address potential issue. This could involve optimizing code, adjusting configuration, or scaling resources to accumulate anticipate demand. Avoiding the downtime also we can say under this category. Anticipating production problem helps in avoiding the unexpected downtime or degrade performance. It allows for a more proactive and strategic approach to maintaining the system reliability and responsiveness. Next one is plan for capacity. So under this category, plan for capacity involves the accessing and preparing for the future response need of a system or application. It's a proactive approach to ensure that the IT infrastructure, including hardware, software, and other resources, can adequately support current and anticipated workload. Main goal is to prevent the performance issue, downtime, or service disruption by ensuring that there are enough resources available to handle increasing demand. So under this category we can say like resource evolution, access the current resource utilization, understand how existing resources such as CPU, memory, storage, and network bandwidth are being utilized in the system, identify the performance bottlenecks, identify any component or process that are limiting the overall system performance. Demand forecasting, analyze the historical data, examine past usage pattern and trend to predict further demand. This includes the considering peak usage period, seasonal variant, and other relevant factors. Performance metrics also we can consider. Define the performance metric, establish key performance indicators that can help to monitor and measure the system performance. Next one is the set the performance target, determine acceptable performance threshold, and define the goals for response time, throughput, and other relevant metrics. In terms of the scaling strategies also we can say like vertical scaling, consider the upgrading existing hardware component to increase the capacity, such as adding a more CPU, memory, or storage to the single review or single server. In terms of horizontal scaling, as we discussed, scale out, scaling and scale out, plan for the deployment of the additional servers or nodes to distribute the load and increase the overall capacity. Infrastructure investment, budget planning, allocate resource and fund for the necessary infrastructure upgrade expansion. Testing and validation, conduct the capacity testing, simulate the different level of the demand to ensure that the infrastructure can handle peak loads without performance degradation. And monitoring and optimization, implement the monitoring solution, use the tools to continuously monitor the system performance and resource utilization, optimize the need, analyze monitoring data to identify area for optimization and adjustment for the capacity accordingly. So this all comes under the plan for the capacity. Next one is the using the monitoring data and optimize performance. So for this we can say like optimized performance involves the leveraging the information collected from various monitoring tool to make informed decision and an improvement in the performance of the system application. In terms of the monitoring metrics, collecting the data we can say employ monitoring the tool to gather the data on various aspects of the system, including the resource utilization, response times, error, error rate, and other relevant metrics. And in real-time monitoring, continuously monitor the system in the real time to capture the fluctuation and the trend. In terms of the performance testing, we can say like validation, throughput testing. Sorry. Utilize the performance testing based on the monitoring insight to validate the optimize before deploy any changes. So this all comes under the performance engineering lifecycle. Sorry. So next one is like I just wanted to share with you some of the information. What are the activities performed by the performance engineer? So main activities like we need to identify poorly written code that may arise the issue of memory like deadlocks, old version of the software, inefficient algorithm. These all comes under the poorly written code. Second one is the database. In database there are some missing indexes, deadlocks. So what is deadlock? So let me explain in a simple term. So let's say there is a two user A and B. Okay, this is user A, this is user B, this is printer 1 P1, this is printer 2. So what happened? A gives a print to printer 1. What printer 1 will do? It will print the print and go to the sleep mode. Similar way, user B give a print to the printer 2, and once the print is completed, this printer will go into the sleep mode. Okay, but when B tries to give a print to the printer 1, what will happen? It is already blocked by printer 1. It will not give a print until unless A release the printer 1. Similar way, if A will try to give a print to the printer 2, so what will happen? It will not able to do the print until unless B release the printer 2. So this condition is called as a deadlock. The next one is unmanaged growth data. So this is nothing but right now we have 35 millions of the test data in our application that we are testing, and next year we are planning to test with higher test data, but we don't have enough storage, so that will comes under the unmanaged growth of the test data. Heavy traffic, load distribution is not properly. If we don't know like what are the business critical transaction and what are the transactions which are taking a high traffic during the in a production, then we in most of the cases users are equally distributed in all the script or all the transaction, so that is not the real case in the production. Next one is DNS, firewall, network connectivity issue, third party systems, shared resource is also one kind of issue. These are the issues that we commonly see as a performance test engineer. Thread related issue, GC problem. GC is nothing but garbage collection problem. Memory related issue, memory leak, improper caching, insufficient memory allocation, domino effect. The problem in the one place will create a problem in the another place. Fake issue like network temporarily slow, some schedule job is going on server, software automatic updates. So these all are the performance and issue that we observed during our performance test. And next one is what are the performance engineer learn skills. So what are the performance engineers should be aware of this all covers here. So basically as a performance test engineer we should have knowledge of the Java, any programming language, .NET, Perl, Python. We should have understanding of the JVM, Java virtual machine. We should understanding of the GC, garbage collection, what is memory leak, code tuning, web development like HTML, JavaScript, CSS. We should at least aware of the any one performance testing tool for creating the script, load runner, JMeter, neoload, any performance testing tool we should be aware to create a script. We should be aware of the creating the workload diagram. We should be get a data from the production and create a workload diagrams to simulate the same load as a production environment. Little slow as we discussed above. Log analysis, we are able to analyze the log. We are able to identify the errors in the log, why it is causing. We are able to understand the what is the ID indicate. Identify the business critical transactions. Test data management should be done by performance test engineer only. Scripting part, we are able to create the script, understand the test report, key bottlenecks, what are the pass fail transactions, what is the throughput, hit per second, error per second. These all key parameters performance engineer should be aware of. This application architecture, data tune database tuning concept. We should be aware of the uh, what are the queries, how to fetch the query, explain plan, AWR report, able to understand what it wants to say, what are the query which is taking a high response time, if it is properly indexed or not. Learn the monitoring. We are supposed to be aware of at least one monitoring tool, app dynamics, dynatrace, nmon, new relic. Operating system that we are using should be our load balancer. If load balancer is properly working or not, if we are able to distribute the load properly or not, that should be like we should be aware of these latest technology like mobile, cloud, containers, Kubernetes, browser metrics, single user performance testing. Learn the profiling tools, identify the bottlenecks, which processes or service having a problem. So these all skills as a performance test engineer we should be acquire. We should be at least aware of these. So let's come back to the course. So today we have covered the performance engineering life cycle and activities performed by the performance test engineer. In upcoming video I am going to cover this Java performance engineering concept, JVM architecture, and all these things. So yeah, thank you, thanks for watching, and sorry there not feeling well, so yeah, some sorry for that, some issue in the video. Yeah, thank you.